All right, we're going to do number 3. Here is the equation that you're given, or the system of equations. You're given y equals negative 3x plus 5. You're also given 5x minus 4y equals negative 3. Now, because this first equation in this system of linear equations is already written in slope-intercept form, we don't have to do anything with it. We can leave that alone for right now. But we need to rewrite this standard form equation in slope-intercept form. So how do we do that? Well, let's leave those two up there as our system. I don't want to mess with those. I will now rewrite 5x minus 4y equals negative 3. Okay, my first step is to subtract 5x from both sides. Okay, they cancel out on the left because 5x minus 5x is 0. And I'm left with negative 4y equals negative 5x minus 3. Okay, so now I have to divide both the left and the right side by negative 4. Okay, so the negative 4's cancel, leaving y alone, which is what he wants. He wants to be alone. Y equals, and remember our little trick, when you've got this big fraction bar and just a number beneath it, you can share that number. Negative 4 can go beneath negative 5x, and it can go beneath negative 3. So I can write this y equals negative 5x over negative 4 minus 3 over negative 4. So clearly I'm not done. Too many negative symbols. So I have y equals, let's think about this. A negative divided by a negative is a positive. So, and maybe the way to think about this is like this. What negative 5x means is that I have negative 1 times 5 times x over negative 1 times 4. Okay, and the reason I'm writing it like that is so you see what I'm canceling out. I'm canceling out those negative 1's, leaving just 5x over 4. Similarly, over here, I've got negative 3 over negative 4. It's just almost exactly like negative 1 times 3 over negative 1 times 4. I'll cancel out the negative 1's, leaving just positive numbers. That's why these become positive. So I just rewrite this. I don't mean to confuse anyone. Y equals 5/4 x plus 3 over 4. Now that was us succeeding in transforming this standard form equation into slope-intercept form. So go up here and write yourself a little arrow saying that you've done this. Y equals 5/4 x plus 3/4. So now that we have both of our equations in slope-intercept form, we can set them equal to one another to solve for x. And that's what we'll do right now. So just going to make a little margin here. And I'll take negative 3x plus 5 and set it equal to 5/4 x plus 3/4. Okay, so I'm trying to get x by itself. So I'll try to bring 5/4 from the right side over to the left. 5/4 x, subtract it out of the right side, and subtract it out of the left side. On the right side, 5/4 x minus 5/4 x cancels. And on the left side, I'm left with negative 3x minus 5/4 x plus 5 equals 3/4. Okay, well, we're in this same situation where the coefficients, or the numbers in front of the x's, that's what we call coefficient. If it's a number in front of a letter, coefficient. The coefficients don't have common denominators, and they need common denominators. So I need something which, when I divide it by 4, gives me negative 3. So what divided by 4 gives negative 3? How about negative 12? So I can rewrite negative 3 as negative 12 over 4. Well, it needs to be a rational number, like a fraction. But, yeah. So negative 12 over 4. If I divide 12 by 4, I get 3. There's a negative. So I still got negative 3. I just changed it into a fraction. So negative 12 over 4x minus 5 over 4x plus 5 equals 3 over 4. So that's where I'm at right now. So the question is, what is negative 12 minus 5? Well, when there's two negative numbers and you're subtracting them, the absolute number is going to get bigger. So it's almost like adding 12 and 5 and then sticking a negative sign in front of it. So what is 12 plus 5? What is 12 plus 5? 17. But we're going to put a negative sign in front of it. So I have negative 17 over 4x plus 5 equals 3 over 4. Okay, so now I need to get rid of this plus 5. He needs to go over to the right side of the equal sign. So minus 5 on both sides. Plus 5 minus 5 cancels. So now I'm left with negative 17 over 4x equals 3/4 minus 5. So we're in this common denominator situation. I want to subtract 5 from 3/4, but I can't do that because they don't have common denominators. So now I need something which, when divided by 4, gives 5. Think about it this way. Multiply 4 times 5. So if you don't know what to do, remember that 5 is 5 over 1. Okay? And so if I want the denominator to be 4, I can multiply the numerator and the denominator by 4. 4 over 4. So that will give me, let me rewrite, negative 17 over 4x equals 3 over 4. Okay, so now I'm with minus 5 times 4 is 20, minus 20 over 4. Well, now I'm in business. Okay, what is 3 minus 20? It's like, so you could say it another way. What's 20 minus 3?
Negative 17.
Negative 17. So, look, let's just rewrite what we've got. We've got negative 17 over 4x equals, and now we've got a negative 17 over 4. Okay? Now, person who I may not name because this is being publicly recorded, how do I get rid of the negative 17 over 4 next to the x? I got to divide it out, right? But how do I divide out a fraction?
Subtract it.
Can't subtract it. I've got to divide it out. I've got to divide a fraction. Divide a fraction by a fraction. To divide a fraction by a fraction, all I do is multiply the original fraction by the reciprocal. Sure. So I'm going to multiply by the reciprocal. 4 over negative 17. Put those in parentheses so you don't lose track of what's going on. Then do the same thing to the right side of the equation. 4 over negative 17. Now, person who may not be named publicly, this is where the real fun comes in. Now, I know you're excited. I want you to calm yourself and prepare for this thrill ride called canceling out numbers. This is literally the most fun part of algebra for me. Okay, so on the left side, what numbers can I cancel out? Okay, and 4. All the numbers on the left side cancel out. What about on the right side? Yeah. So everything canceled out. What's left? X equals, and then this is a thing we got to learn. When I cancel everything out, all that's left is a 1. It doesn't go to 0. It's leaving 1. Okay? So your temptation is to say, well, I canceled everything out. That must mean it's just 0 remaining. No, what it means is 1 remains. Now, as impossible as it is to believe, after 13 minutes, we have not yet solved the problem. We have not yet solved the problem. But we are close. So we are really close, as a matter of fact. We now know what x is. And remember, person who I may not name publicly, as you so eloquently stated, the solution to any system of linear equations is going to be the point on a graph where the lines formed by those equations intersect. So we have found part of that coordinate. Okay? So x comma y, right? We have found the x. The x is 1. So now we need to find the y. Well, thankfully, it just so happens that we were given y equals negative 3x plus 5. So if I plug in what I have for x, which is just 1, into this little formula, it should spit out y. So here's what we can do. Come back down here and write y equals negative 3, open paren, close paren. Leave a space, plus 5. Because I'm going to replace that x with the x value I found, which was 1. So I'm going to write in the 1 for x. So now I have y equals negative 3 times 1, which is just negative 3, plus 5. So here's the question. What is negative 3 plus 5? What's negative 3 plus 5? What? No, it's like when you have a positive number that's bigger than the negative number, your result is going to be positive, and it's almost like saying 5 minus 3. You can't do math when I'm staring at you. Okay, so what is 5 minus 3? 2. So y equals 2. All right, so here's the fun part, comma. So we go back to our little answer area here, 1, comma, 2. So just so we understand what this is, we got two equations here. Y equals negative 3x plus 5, and y equals 5/4 x plus 3/4. If I were to graph those using a graphing calculator, they are going to cross at 1, comma, 2. So just to finish this off, and then we'll be done, we will do exactly that. We will graph negative 3x plus 5, and we will graph 5/4 x plus 3/4. Okay, and what we're hoping is that they cross at 1, comma 2, where x is 1 and y is 2. So the way I find out is, now that I see that point right there, I hit second trace, intersect 5, enter, enter, enter. Intersection, x is 1, y is 2. A beautiful confirmation of our estimation using substitution. So we solved the system of linear equations using substitution, and we found the intersection point of those two lines. And that is the answer to number, what problem was this? 3. Was it number 3? Yeah, it was number 3. The answer to number 3. Thanks.